All right, today we're jumping right into one of the most incredible frontiers in all of technology, the quantum future. We're going to chart the path from what's happening in labs right now to the world-changing machines of tomorrow.
So I want you to just start with this one question in your head. Seriously, what if we had a computer that could solve problems that we currently think are literally impossible? I mean, challenges that are completely out of reach for even the biggest supercomputers on the planet. That's the promise we're talking about. And believe me, it is not science fiction anymore.
So what's the secret sauce here? Well, it all boils down to this one fundamental difference. You see, a classical bit, the thing that runs basically everything you own, is like a simple light switch. It's either on or off, 0 or 1, that's it. But a quantum qubit, now that's more like a dimmer dial. It can be a 0, it can be a 1, or, and this is the mind-bending part, thanks to something called superposition, it can be both 0 and 1 at the exact same time. Now that isn't just a small tweak. This ability to explore all these possibilities at once is what gives these machines their absolutely staggering exponential power boost.
But, going from that amazing concept to a machine that you can actually use, well, that is a massive engineering challenge. So let's talk about the two giant hurdles that scientists are laser-focused on clearing right now as they build out this quantum future.
Okay, first up is just scaling the hardware. That means we have to go from the machines we have today, which have maybe tens or hundreds of these qubits, to systems that are way, way bigger. And the second huge one is mastering error correction. See, qubits are unbelievably sensitive. They're fragile. So we have to figure out a way to make their calculations totally reliable and robust. And when we say scaling, we're not talking about a small jump. The ambition here is insane. The target isn't just a few thousand qubits. The real goal is over 1 million reliable qubits, all working in perfect harmony. That number, right there, that's the leap from what we have now, these experimental prototypes, to a truly powerful fault-tolerant machine. And fault-tolerant is key. It means it's a computer that can actually fix its own mistakes as it goes and run long enough to solve those impossible problems we talked about.
So how in the world do you make 1 million super fragile qubits reliable? Well, that's where this brilliant idea comes in: quantum error correction. The basic concept is kind of like this. You use a whole team of those fragile physical qubits just to create one single, super robust logical qubit. It's like they're all working together to protect the important information, shielding it from all the noise and errors in the environment. This is the trick that could make large-scale quantum calculations finally possible.
Now, there's a really common misconception that these quantum machines are just going to replace our laptops and our phones. That's really not the case. The future of computing is actually a team effort, with the classical computers we already have acting as a kind of co-pilot for their new quantum partners.
Look, quantum computers are specialists, right? They're not going to be running your email or letting you scroll through social media. Classical computers are still going to handle the huge majority of everything we do, like 95% of the work. But that other little slice, that 5% you see there, that represents the kind of crazy, complex problems that are totally impossible for even the best classical machines. The key takeaway is they're going to work together in a hybrid system, each playing to their strengths.
Okay, so we've covered the what and the how. Now for the most exciting part, the why. Let's dive into some of the incredible, truly world-changing applications that this new quantum power is going to unlock. This is where it gets really fun.
In science and medicine alone, the impact is going to be absolutely profound. Just imagine being able to simulate a complex molecule with perfect accuracy. We could design brand new drugs in a fraction of the time it takes today. Or think about designing revolutionary materials from the atom up. We're talking about things like perfect superconductors or batteries that are so much more efficient. We could even model our planet's climate with a level of detail that we've only ever dreamed of.
And it definitely doesn't stop there. In industry, these machines could solve logistics problems so complex that we call them impossible right now, like perfectly optimizing all the shipping routes for a global company in real time. And in finance, they could analyze financial risk and build investment portfolios with a level of sophistication that's just unimaginable with today's technology.
Of course, a technology this powerful doesn't just come with amazing possibilities, it also comes with some serious responsibilities. We really have to start thinking about the new rules for this quantum world and navigate all the societal and ethical stuff very, very carefully.
The most immediate thing people worry about is cybersecurity. A powerful quantum computer could, in theory, break a lot of the encryption that keeps all of our data safe right now. That's the threat for sure. But here's the fascinating twist. The same quantum physics that creates the threat also provides the solution. We can develop new quantum-safe cryptography that is secure even from a quantum computer.
So we're basically in a race right now to build and roll out these new security standards before the code breakers get here.
And beyond security, there's this really big question of access. How do we stop this incredible tool from just making the gap wider between the people who have access to it and those who don't? It's a huge debate, and it really points to the fact that we're going to need international cooperation and some smart planning to make sure the benefits of quantum computing are shared by everyone, not just a select few.
You know, when you boil it all down, this quote really says it best. This isn't just about building a faster computer. It is a fundamental paradigm shift. It's something that could completely redefine the very limits of what humans are capable of solving.
So the quantum frontier isn't some far-off dream anymore. It's here. We are exploring it as we speak. So the real question has changed. It's no longer if we'll have this incredible power, but how are we, all of us, going to choose to use it to redefine what's possible?